Today we will try to find several solutions of Pell's equation. So what is Pell's equation? Pell's equation looks like x square minus ny square is equal to p, where x and y and p are all integers. And one more thing, here n is not a perfect square. If it is a perfect square, then it is not called a Pell's equation. And we can simply solve it by using factorizing left hand side and right hand side. So suppose you have equation x square minus 4y square is equal to 1. So this is a perfect square. So we can factorize it as x minus 2y into x plus 2y is equal to 1. But the problem is when this is a Pell's equation means this is not a perfect square, how to factorize it and how to get integer solutions. Let's take an example, x square minus 2y square is equal to 1. So initially we can get one solution by just guessing. So when value of n is small like here, initial solution is easy to guess. Here 3 comma 2 works. 3 square minus 2 into 2 square is equal to 9 minus 8 is equal to 1. Let's call it as fundamental solution x0 and y0 is equal to 3 comma 2. Since x0 y0 is a solution of this equation, let's plug in and get first equation as x0 square minus 2y0 square is equal to 1. So using this equation, we will get several solutions. For this, we have to factorize this equation x0 minus root 2 y0 into x plus root 2 y0 is equal to 1. Now you see right side is 1. So any power of 1 is equal to 1, always 1. So using this property, we can produce many solutions. Let's square both the sides. So we get x square minus root 2 y0 square x plus root 2 y0 square is equal to 1. We get x0 square plus 2y0 square minus root 2 into x0 y0. Second bracket also we get the similar way x0 square plus 2y0 square minus root 2 into x0 y0 is equal to 1 because 1 square is 1. Now let's call this as x1 and this as y1. X1 is equal to x0 square plus 2y0 square and y1 is equal to 2x0 y0. So how this equation looks like, x1 minus root 2 y1 into, here also we have the same thing, this is my x1 and this is my y1. x1 plus root 2 y1 is equal to 1. Isn't it looks like this exactly same as this one? It just looks like we have replaced x0 with x1. So that means x1 is a solution. Let's see if it works. So from here we can calculate x1 and y1 and see if it works. So x0 value is 3 square into 2 square is equal to 9 plus 8 is equal to 17. And this is equal to 2 into 3 into 2 is equal to 12. Let's see if it works. X square minus 2y square is equal to x1 square minus 2y1 square is equal to 17 square minus 2 into 12 square. 289 minus 2 into 144 is 289 minus 288 is equal to 1. Bingo. We got another solution, 17 and 12. So 17 and 12 is another solution. Similarly, we can cube this equation and we get another solution. Let's take another example. X square minus 3y square is equal to 1. Let's guess first solution as x0 comma y0 is equal to 2 comma 1. It's easy when n is small. So 2 square minus 3 is equal to 4 minus 3 is equal to 1. And similarly, for second solution, we can try x1 is equal to x0 square plus 3y0 square is equal to 2 square plus 3 into 1 is 4 plus 3 is 7. And y1 is equal to 2 into x0 into y0 is equal to 2 into 1 is equal to 4. Let's try this. If this works here, so it's 7 square minus 3 into 4 square is equal to 49 minus 3 into 16 is equal to 49 minus 48 is equal to 1. So we have taken an example where p is 1. Let's take another example where p is not 1 but something else. X square minus 5y square is equal to 11. We can easily check that 4 comma works here. 4 square minus 5 into 1 is equal to 16 minus 5 is equal to 11. So if we factorize this, x minus x plus root 5 y into x minus root 5 y is equal to 1. And if we plug in this, we get 4 plus root 5 into 4 minus root 5 is equal to 1. Let's introduce few more symbols here to get many more solutions. Let's call this as omega and this as omega bar. So omega is equal to 4 plus root 5 and omega bar is equal to 4 minus root 5. So produce more solution, we need to solve one more equation when this equation has right hand side is equal to 1. So let's take x square minus 5y square is equal to 1. Again, we can check that 9 comma 4 works here. 9 square minus 4 into 4 square is 81 minus 80 is equal to 1. So again, let's factorize this. X plus root 5y into x minus root 5y is equal to 1. And plug in these values here. 9 plus 4 root 5 into 9 minus 4 root 5 is equal to 1. And again, introducing few more symbol here. Let's call this as sigma and this is sigma bar. So sigma is equal to 9 plus 4 root 5 and sigma bar is equal to 9 minus 4 root 5. So now, using this omega and sigma, we can produce infinitely many solutions. We claim that sigma omega to the power n is also solution to this equation. For example, if we take n is equal to 1, sigma into omega is equal to 9 plus 4 root 5 into 4 plus root 5, which is our omega, is equal to 36 plus 9 root 5 plus 16 root 5 plus 20 is equal to 56 plus 25 root 5. So if we take x1 is equal to 56 and y1 is equal to 25, this is also a solution to our Pell's equation, this one. Let's try if this solution works. X1 square minus 5 y1 square is equal to 56 square minus 5 into 25 square. We can use the calculator here. 3136 minus 3125 is equal to 11. So we can produce as many solutions we want. If we take different values of n, we will produce infinitely many solutions like sigma omega square, sigma omega cube, dot 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 dot. We also claim that sigma omega bar to the power n are also solution to this Pell's equation. So again, we can prove by an example. Let's say n is equal to 1, then sigma into omega bar is equal to 9 plus 4 root 5 into 4 minus root 5. Let's multiply them and see if we can produce another solution. This is 36 minus 5 into 4 plus 9 root 5 minus 16 root 5 is equal to 16 minus 7 root 5. Let's call these values as x2 is equal to 16, y2 is equal to 7. Let's see if we produce another solution. So x2 square minus 5y2 square is equal to 16 square minus 5 into 7 square is equal to 256 minus 245 is equal to 11. So we are able to get another solution. So that means we have another set of solutions, sigma omega bar to the power n. We change the value of n, we get as many solutions we want. So sigma omega bar is a solution, sigma omega bar square is a solution, sigma omega bar cube is a solution. So we got so many solutions with this combination and with this combination. Let's review what we taught in this video. We were trying to solve a Pell's equation x square minus 5y square is equal to 11. And one of its solution we guessed and we named it as sigma, and sigma conjugate is equal to 11. We also solved Pell's equation x square minus 5y square where left hand side is equal as my original equation, but right hand side we put 1. And first solution of this equation we named as omega. So omega into omega bar is equal to 1. And using sigma and omega, we produce infinitely many solutions. Solutions were sigma omega to the power n and sigma omega bar to the power n. So solution will look like sigma omega square, sigma omega cube, and dot 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 infinite. Here also sigma omega conjugate square, sigma omega conjugate cube, and again they are infinite. So now what we will do, we will show that this solution works. We have seen for n is equal to 1, but we will show that all solution works. So for this, we need to use the conjugate property of complex number, because real number conjugates also follow the same rules. If you have z1 and z2 two complex number and we take the conjugate, we get z1 conjugate into g2 conjugate. And second property we are going to use is g1 conjugate to the power n is equal to g1 to the power n and then take the conjugate. Now one more thing I want to highlight. When I have a solution sigma for this Pell's equation, then sigma and sigma conjugate is equal to 11. When I have a solution omega for this Pell's equation, then omega and omega conjugate is equal to 1. So that means if I am claiming that this is my solution, then this multiplied by its conjugate should be equal to 11 in order to satisfy that it's a solution of this Pell's equation. So let's see if we can prove it. Sigma omega to the power n into, we are taking conjugate, sigma omega n and conjugate. Now we are applying this property here is equal to sigma omega to the power n, sigma conjugate into sigma to the power n conjugate. Let's combine these two terms and these two terms. Sigma into sigma conjugate into omega to the power n into omega to the power n conjugate. Now we are going to apply this rule. This is equal to sigma conjugate into omega to the power n into omega conjugate to the power n. Now we know sigma into sigma conjugate is equal to 11. This was the first solution we guessed for our Pell's equation. And here we see n, we can take this n outside, omega into omega conjugate to the power n. And this solution was the solution for Pell's equation where right hand side was 1. So omega conjugate is 1. We can place this value here. 11 into 1 is equal to 11. So that means that this is a solution of our Pell's equation, x square minus 5y square is equal to 11. I hope you enjoyed the video. Thank you so much.